So we'll continue that discussion about Oracle Database 11G automatic storage management. This would be the second part of a four-part discussion that I'm planning to do on ASM. Uh, Yesterday we left that video when uh, we discussed thoroughly about the startup of an ASM instance. Now from this point onwards I am going to build up the second part where an ASM instance does not have a data dictionary. I said yesterday. So the only way to connect to an ASM instance is by using the system privileges. So you cannot create user accounts in an ASM instance the way you could create a database user account, because it does not have a data dictionary. All the users that you create in a database are database authenticated, which means the user and the encrypted passwords are stored in the database in the system table space in some table, let's say user dollar. But in case of an ASM environment, since it does not have a database of its own, neither it has its own data dictionary, so the only way you can use is to have special privileges. And those special privileges in case of ASM are sysASM. For example, you might create a group at a OS level, the way we create O install and DBA. You might want to create a group, let's say OS ASM, and you might want this during installation of your grid infrastructure to be selected as sysASM. Now when you say sysASM, this is the highest authority in ASM. The way you have sysdb in case of database, the highest authority. In case of an ASM environment, sysASM is the highest authority. Although you also have sysdba privilege in case of ASM, uh, and it's somewhat privileges wise is somewhat inferior to what is offered to you by sysASM. So in case of sysdba for a database, he is the highest authority. In case of sysdba, in case of ASM, he is the second highest in the command line. The highly privileged account is sysASM. Sysdba can access to the data store, has access to the data stored on ASM. sysdba can create and delete files, grant and revoke file accesses. But destructive operations on the disk groups cannot be performed by sysdba. They can only be performed by sysASM. And then the third in the command hierarchy is sys operator. You might want to create a group something as OS operator for ASM, and the sys operator user special privilege has limited privileges to start and stop the ASM instance along with the set of non-destructive alter disk group command. So any alter disk group that is non-destructive in nature can be practiced by sys operator. But the highly privileged account is sysASM, who can do everything. The sys user on ASM is automatically created with the sysASM privileges. So when you install the grid infrastructure, there is indeed a user called as sys in case of ASM, and that the user is automatically granted with sysASM privilege. During the installation, another user is also created called as ASM SNMP, and this user is created with sysdba privileges and is normally used for monitoring the Oracle ASM instance. So there are two pre-created user accounts, as I said, sys and ASM SNMP. In environments where there is a strict separation of duties, where an ASM administrator has to be a different person than a database administrator, you might create these 6 sample operating system groups and then can create two user account, let's say Aura Grid and Oracle. Using Aura Grid, install the grid infrastructure software. Using the Oracle account, install the RDBMS Oracle software, and then each of those users Aura Grid can then be made a member of ASM admin, ASM DBA and ASM operator. These are nothing but the operating system groups I am talking about. And so in short, what I am saying, if you want ASM to be separately monitored, you can create a user, let's say Aura Grid, who is a member of ASM admin, ASM DBA and ASM operator as his secondary group membership. For primary group membership, you can make him a member of oInstall group. For DB, you can create an user account Oracle whose primary group must match to that of your ASM admin's primary group, and then he could be made a member of DBA and operator. So anybody who is a member of this group, that is OS ASM, in my case the literal value for that OS ASM is ASM admin, he can log in as sysASM. Anybody who is a member of OS DBA, in my case the example is ASM DBA OS group, then he could log in as sysDBA. If you create an OS group and the literal value, let's say in my implementation, is ASM OPER, then the person could log in as sysOPER. Aura inventory is the ownership of your central inventory, who can go and modify the values from the central inventory. Normally this is required during OUI, when Oracle Universal Installer is invoked for grid infrastructure installation or for that matter RDBMS installation. So there must be a write privilege and also a read privilege to read existing Oracle homes from the central inventory. And once my software is installed, I must be able to go and update that central inventory file with the existence of my new Oracle home. So who should be having those privileges? So anybody who is a member of oInstall group. Next is for the DB part, you need DBA. It's a privileged account for OS DBA, which is literally mapped with DBA in our case, and anybody who is then a member of a DBA operating system group would be able to log in as sysDBA. There is another implementation for special privileged called as sysOperator, which is literally indicated as OSOPER. In my case, let's say I have created an equivalent group for this as OPER, then I would make my Oracle account a member, secondary member of OPER group. Then as an Oracle user, I can also log in as sysOPER. So if you want a strict separation of duties, a point to remember, you can change the implementation style like this. However, in our case, we have implemented everything as a single user. So in our case, where there is no separation of duties, we created an user account called as Oracle, who is primarily a member of oInstall, DBA and optionally OPER group. One point to remember here is, if we are talking about separation of duties, the primary group of both the users must match. Otherwise, as an Oracle user, we won't be able to access ASM. So the primary group must match. For ASM, you can set remote login password file parameter to exclusive. This is for using password file authentications. So if like a database allows you a remote connectivity over the network, where a remote person can connect to your database either as sysDBA or sysOperator. Now to make this happen, first the database must use a remote login password file value to exclusive or shared. On top of that, there must be a password file and users must be added to a password file. On the similar lines, if somebody wants to log into an ASM instance remotely with sysASM, sysDBA or sysOperator privilege, your ASM instance must have its own password file. The password file in case of ASM is automatically created by the Oracle Universal Installer, and if you want, at any given point in time, you can also recreate it using Aura PWD utility, the way you create it for the database environment. Once you have this password file, users can then be added to the ASM password file using either grant command, the way we do in database. You connect as sysDBA and then say grant sysDBA to Tom. Then Tom's user ID and encrypted password will be automatically stored in the password file. Subsequently, Tom can then connect from any remote network terminal with his user ID and password with the qualifier as sysdba. On the similar lines, you can use grant command in case of ASM to get those user accounts added to your password file. Now, one good thing about ASM is if you are not a SQL star plus tool freak, then you can use also another interface provided to you, that is ASMCMD. ASMCMD is the command line utility provided for ASM administration. So whatever is literally possible using SQL star plus, almost all those activities can also be accomplished using ASMCMD command prompt. So here I am on the server. I am logging myself in as Oracle. Since I do not have the environment file, I would try to set this for the first time. Remember, ours is a clustered implementation, so name of our ASM instance is plus ASM1. Good enough to get started off with these variables, environment variables. I would going forward store this in a grid.env file, so I don't have to define it every now and then. So when I say which ASM CMD, the ASM CMD utility comes from the grid home bin directory. You can launch that by saying ASM CMD, which takes you to the ASM command prompt. If not, additionally you can launch it with -p argument, which also shows you the path, the present working directory where you are into. Once you launch ASM CMD, ASM CMD is a command line administrative interface for ASM environments. So whatever you can accomplish using SQL star plus, pretty much all those things can also be accomplished using ASM CMD command prompt. To launch it, you can say ASM CMD optionally followed by -p. The root of ASM is indicated as plus. So you can see here plus. A plus indicates the root of ASM. The way you have a root of your Unix file system indicated as a slash, on the similar line the root of an ASM is indicated as a plus. You can use some of the supported commands. I am using ls-l is one of the supported commands. I can see there is a disk group called as data. Once I go to the disk group called as data, you see my path is changing, which indicates my current working directory. That is possible because I launched using -p argument, which prints my present working directory as part of the command prompt. When I say ls-l, I can see what all directories are there. I can go to rackdb. You see my path is changing now. Now within the rackdb there is a directory called as control file, data file, online log file, parameter file, temporary file. I see there is something quite similar to a symbolic link notification or a symbolic link which is pointing to something else. I am going to data file directory. Say ls-l, I can see all the files here. Now remember, this ls-l is not the operating system command, but a simulation of or an implementation which is very ASM specific. So they just simulated the ls command that we often use on the operating system as if it's an ASM CMD command ls. So it shows you an illusionary depiction of how ASM internally is implemented. So ASM CMD provides an illusion of ASM implementation. Remember, this is just an illusion. Otherwise, what is an ASM? ASM is an instance which manages a disk group. Disk groups are never formatted block devices in case of Linux, or raw devices in case of any other Unix. Grouped together inside a disk group where the metadata is purely managed by ASM. So there is no question of something called as directories, subdirectories, root, files within those subdirectories. This is all an illusion. It's all like a PC Sarkar, Maya Jal. It's just a depiction, illusionary depiction of how ASM is implemented. Ultimately, I am talking all about the metadata which is stored in the disk header, made in a more presentable way using ASMCMD command prompt. So when I look into this, I can jump back to the root the way you say cd slash. On the similar lines, you can say cd plus to jump onto the root. So within ASM on the root, you would find all the disk groups. Within a disk group, you will find all the databases that are using this particular disk group, or the name of the cluster using this disk group. So if I go to data, this is not the name of my database. This is actually the name of my cluster. Remember, cluster also stores its voting disk, ASM parameter file, ASM instances parameter file, and Oracle cluster registry onto the ASM disk group. Although all other files are you can see them except for the voting disk. Voting disk is pretty much there, but there is no way you can list the voting disk. It is there, but you cannot see it. So you can only see ASM parameter file and OCR file. So the physical implementation of a voting disk is done, but the logical representation is not made accessible using ASMCMD. The physical and the logical implementation for ASM parameter file and OCR file is both available. So if I go to OCR file and I say ls-l, this is nothing but my Oracle cluster registry with the name registry.somenumber.somenumber. So ASMCMD provides an illusion of ASM implementation, and as I said earlier, it's an administrative interface. Now by administrative interface, I mean you can use any of these supported commands on the ASM command prompt. The supported commands include MD backup for metadata backup, MD restore for metadata restore. Remember, I said ASM manages its own metadata in the participating disk itself. So you can take a backup of it, you can restore it if required. Least attribute, set attribute. You can use ASM implementation of OS like commands: cd, cp, disk usage, find, help, ls, ls clients, list connected clients, lsdg, which is to list the disk groups, lsof, list open files, mkalias, mkdir, pwd, rm, rmalias. These commands, although they sound familiar, remember none of them is a OS command. They are the OS like commands implemented for ASM. You can also use commands related to disk groups such as chdg, change disk group configuration, chkdg to check the consistency of a disk group the way you do fsck, file system consistency check. Drop dg, you can also list out the disk groups IO statistics. You can list the physical disk lsdsk, lsod, mkdg, mount, offline. So these many commands are the ones which are supported. Anything other than this is not supported on ASM command line. So there are two ways to invoke it. Either say ASMCMD optionally followed by -p if you want, followed by, once you are on the prompt, say the command lsdg. If not, you can directly type ASMCMD lsdg. So this will not take you to the prompt. From being on the operating system, you can still get the necessary commands executed. On the similar lines, I could have said lsdsk, or for that matter any other command. So as of now, lsdsk is listing me only those two disks that I am using. Remember, we have 4 learns, out of which we have consumed only 2. Those 2 learns we have allocated to a disk group called as data. Remaining 2 disks are still free. How do I know? I can also go and get connected to SQL star plus. Remember, I am connected to an ASM instance. Then I can say select star from $ASM underscore disk, and it will show me what is the status of the disk. Member, provisioned, provisioned. So 2 disks are showing the status as member because they are actively participating in a disk group named data, while 2 disks are freshly provisioned, stamped. We haven't consumed them yet so far. So that's why the status of the other 2 disks, disk 3 and 4, is showing as provisioned. Now coming back to our password file discussion, you can use the regular query to find out which all users are added to the password file. As I said earlier, OUI would add these 2 users for you by default. sys would be added as a sysdba, who is automatically sys operator and sys ASM also. ASM SNMP is by default used for monitoring, who is granted with the privilege sysdba only. Other users, you can also use ASMCMD command way of looking at it. The same thing using ASMCMD. So I said ASMCMD LSPW users. So list the users which are currently there in my password file is what it means. The same output can be seen using ASMCMD LSPW user. Now some of the important points you may want to note. One server can have only one ASM instance. One ASM instance can have up to 64 disk groups. One ASM can service multiple databases. One ASM instance can service multiple databases or database instance. However, they must all reside on the same server. Means a physical co-location is mandatory. You cannot say my ASM runs on machine 1. Can I have my database running on machine 2, store its files on the remote ASM instance? Not possible. A physical co-location is mandatory. One disk group can have up to 10,000 disks. One database can use multiple disk groups. So I am having a database, let's say RACDB. Some of the data files from my RACDB database are stored on disk group data. Some of them are stored in archive data. Some of them are stored elsewhere. So one database can store its files onto multiple disk groups. The converse is also true. One disk group can be used by multiple databases. So the relationship between the databases and the disk group is many to many. ASM instance must co-reside on the same machine as the database instance. So you must remember all these points. So physical co-location is one of the important criteria. Now implementation wise, if you want to give an analogy, then you can think of an ASM implementation like a client server implementation, where an ASM environment or the ASM instance acts as a server, and other utilities such as database instances, ASMCMD, SQL star plus, the grid infrastructure services, XML DB XDB acts as a client. So when I go to ASM and I say select star from $ASM client, I can see who all are connected. So I can see the instance RAGDB1 is a client for my ASM. You could have done the same thing using ASMCMD LSCT. LSCT will show you the connected clients. So the grid infrastructure, the cluster implementation is itself a client to an ASM. Apart from this, understandably, RAGDB instance, RAGDB1 is also one of the clients for your ASM. So think of this like a client server implementation. Whatever you do using SQL star plus ASM CMD XDB, which I am going to demo you at a later stage, everything acts as a client where ASM serves as a server. So ultimately all of them has to get connected to the ASM instance so as to do something related to ASM. There are a lot of background processes. All of them you may or may not see all in one glance. Uh, there are standard processes such as DBWN, LGWR, PMON, SMON, CKPT. They are still required in case of ASM, however, doing somewhat a different job. So they don't do the same job as in case of uh, rather your database implementation. So there is no dirty block in case of a ASM instance, right? So database writer would still be required, but will be doing somewhat a different job. That is to do a metadata management. Writing of metadata, writing of transient logs will be uh, the job of those background processes. If an ASM instance crashes, a SMON is still required. If a database connected client abruptly terminates a connection, PMON is still required, but doing somewhat a different job. So DBWN, CKPT, LGWR, PMON, SMON are still the mandatory background processes required for your ASM. However, from context wise, if you see, they are doing somewhat a different activity, because ASM only manages metadata and transient system logs which are kept in the disk itself. So only things related to that would be done by those respective background processes. When I say PSS-EF grep ASM, you can see the background processes. So you have here SMON, CKPT, LGWR, DBWN, and somewhere down under you would also see the other processes. But the ones that I am primarily interested in the mandatory background processes. Apart from that, there is a memory management required. Remember we said memory underscore target equal to 272 MB. So there is still a memory juggling required between SGA and PGA. Although I said the memory requirement footprint wise is very tiny footprint for an ASM. 272 MB of memory is good enough for entire SGA and PGA implementation, out of which we have only made a categorically an assignment for large pool of 12 MB. That is because you can have actual rebalancer processes numbered up to 11, and we don't size memory as odd numbers, we size it in the multiple of 2. So if you size it to the nearest higher number, it makes it 12 MB, although 12 MB of that entire memory would not be required, because you actually in a worst case you might run 11 actual rebalancer processes. Apart from this, very ASM specific processes that you can see includes RBAL, the rebalancer. Remember I said it's a supervisory process. It only acts as a supervisor during the rebalancing. The actual worker processes, those who would migrate the data from a existing disk to a new disk in case of a disk addition, and from an existing disk to the remaining disk in case of a disk removal, is actually carried out by ARBN. The ARBN processes are the actual rebalancer processes. So I can see here there's an RBEL process. And if I trigger a manual rebalancing, you might see I can see the ASM power limit is set to 1. So there, if I trigger a rebalancing, automatically you might see an ARB0 process starting. But it shouldn't hold my whole thing, so I don't want to fire it. We'll do it at a later stage when we create some other disk group, or when we see a practical on how to add a new disk to an existing disk group. That time it will anyways trigger the ARB, and you can see it as one of the background processes. Gmon is a very ASM specific process, background process, and is responsible for managing the disk level activities such as dropping a disk or making it as an offline, making a disk offline, or during advancing the compatibility of a disk group. So each disk group would have three types of compatibility. Anyways, that's one of our discussion which is yet to happen, called as, there is indeed an init or a parameter also for ASM. I am listing the attributes. There are three compatible parameters called as compatible.asm, compatible.rdbms, and in some cases compatible.advm. More on it in a later session. But whenever you change this compatibility value for a disk group, then Gmon would come in picture. Remember, this compatibility has to do with the metadata. So once we are into that compatibility discussion, I will explain what do you mean by compatibility of 10.1, 10.2, 11.1, 11.2. How the metadata over a period has changed. Then there is a process called as mark. The job of mark is to mark ASM allocation unit as tel whenever needed. So some allocation units over a period may get tel, and the status is indicated by the mark process. Now you would come to know what is that allocation unit only when we proceed to a disk group discussion to understand how contents are striped and then stored onto a ASM disk group or within a failure group. That time it will be clear. Then there are one or more than one ONNN processes. These are one or more ASM slave processes forming a pool of connections to the ASM instance for exchanging messages. So whenever a client gets connected to the ASM, which acts as a server, a message exchange has to happen between the client and the server. That is normally coordinated by those ONNN processes. Apart from this, you might have PZ9 N processes, which is one or more parallel save processes used in fetching data on clustered ASM installation from $GV views. So these background processes which are started with PZ9, every time you query something which queries the metadata, those background processes will be spawned, and they help in getting the metadata in a presentable manner when you query the dynamic performance views related to ASM. Apart from this, you might go for clustered ASM implementation. A clustered ASM implementation is when you have more than one ASM instances running on multiple machines but managing the same set of disk groups, is what we understand by clustered ASM implementation. You can see the cluster database parameter is set to true, which means in my case it's not a standalone ASM implementation, it's a clustered ASM implementation. And to prove this, I am querying gv dollar instance. V dollar instance shows me local dynamic performance view contents. GV dollar shows me global dynamic performance view content, where I can see there is an instance named plus ASM1 running on alpha. There is another instance called as plus ASM2 running on beta of the version 11.2020. This shows that it's a clustered ASM implementation. And whenever there is a clustered ASM implementation, you would see additionally LMON, LMD, LMS, LCK, which are required for clusters, whether it's a database cluster or an ASM cluster. LMON stands for the global on queue service, monitor rather. LMD stands for the global on queue service. LMS stands for the global cache service, and LCK stands for the lock monitor or the locking process. Now more on these background processes once we move on to the database part. During database I am going to talk about two different functionalities called as GCS, global cache service, and GES, the global on queue service. That time you will come to know what is the difference between LMON, LMD, LMS, LCK, and what is their role into either GCS or into GES. If you have implemented the 11G release 2 new feature called as ADVM, ASM Dynamic Volume Management, then additionally you would see these three background processes called as VDBG, VBGN, and VMB. The VDBG background process is the volume driver background process which forwards ASM request to lock or unlock and extend for a volume operations to a dynamic volume manager driver. The VDBG is a fatal background process, so the unplanned death of this process brings down the ASM instance. Now as of now we haven't implemented ADVM, so in our case that process won't be there. But in one of the topics we are going to implement ADVM, we are going to create a volume. Later on that volume we will try to format it with a local file system and get that volume mounted as if it's a fresh disk added to your operating system. And in another example we are going to create another volume. That volume we would format it using ACFS, ASM cluster file system, and once formatted we will get it mounted simultaneously on alpha and beta, which will act as a shared storage. That time you will see those automatically, those other background processes that we are talking about. See here the PZ9 process, PZ9N process. So VDBG will only come in case of ADVM implementation. On the similar lines, if you have implemented ADVM, you might also see VBGN, which is a volume background process. It waits for request from the dynamic volume management driver, which needs to be coordinated with the ASM instance. An example of such a request would be opening or closing an ASM volume file when the dynamic volume manager driver receives an open for a volume, possibly due to the file system mounting request, or close for a volume because of an unmounting request. Then it is coordinated, it needs to be coordinated with the ASM instance. The process VBGN comes in picture then. The unplanned death of these processes do not have any effect on ASM instance because they can be spawned at any point in time. Apart from this, there is VMB, which stands for volume membership background process, which coordinates cluster membership for ASM instances. So as and when a new ASM instance joins in a cluster, that is coordinated by VMB processes, again in case of ADVM implementations. You don't see them otherwise. One important process that we didn't talk about is ASMB. ASMB stands for an ASM bridge For every client that connects, database client that connects to your ASM instance, ASM opens a communication bridge with the database instance, and that bridge is utilized for passing on of messages between the ASM and the respective database instance. Now consider a case that we have a RACDB1 instance implemented here. You can see there's a ASM bridge open. The bridge on one end connects to ASM, on another end it connects to the database instance. There is also an equivalent bridge on the database side. So this is actually ASM end of my bridge. There is also the database end of the bridge. If I say ps-ef grep ASMB, so you see this is the bridge. The background process that spawns this bridge is the ASM side's ASMB process. On the similar line, database also has a bridge. This is the background process related to my database. It opens the other end of the bridge. So every time a communication channel has to be established, automatically a bridge would be opened. Now, as of now, I can see, I would open another session. I want to open the background dump destination of my database. And want to keep on doing the tell. This is my observation line. On the similar lines, I want to do a tell-f of whatever is here. I want to open the third session, and then I want to see what happens when a bridge is killed. So this is the background process related to my bridge. I am going to close this bridge, this process. Prior to that, what is running? Both the instances are running. I want to kill the bridge and see what happens. See what it says? This is the alert log of my database. System state dump whatever. Let it settle down first. It says system state dump abnormal instance termination, which means my instance crashed the moment the bridge was broken. Then it says pmon is now doing a recovery of whatever. Then it immediately started the instance. Now how come my instance started automatically? OHASD, the Oracle restart capability. The moment some service goes down, the Oracle restart will start it up because it detects it as an abnormal termination. So the moment my bridge was broken, my instance crashed, but because there was an Oracle restart product implemented, it restarted the instance again back to normal. So I'm back to normal. I want to check what's the alert log of ASM showing then. ASM client RACDB disconnected unexpectedly. Check the alert log. Client RACDB registered again. So in a moment's time it stopped. OHSD restarted. It got again connected back to this one. So bridge is important for communication between the RDBMS client and the ASM server. So very important discussion. Next, I want to focus on, so in this session I am going to talk about components that you can place onto the ASM disk group. So only these many files you can keep on ASM disk group. So there would be some exceptions to this one, the files which you cannot keep on the ASM disk group. So let's talk about what you can keep on a disk group. You can keep your control file of your database, flashback logs if you have enabled fast recovery area, data pump dump sets. So if you are taking an export dump, your data pump dump set can be kept in a directory. That directory object is pointing to some disk group, which is possible. Your data files, SP file of your database. If you have enabled the data guard configuration, then you can also keep the data guard configuration file. You can keep your temporary data files or temp files. RMAN backup sets can also go to a disk group. RMAN block change tracking file. Your online Redulog files. You can keep your RMAN image copies also on a disk group. You can keep OCR, the Oracle Cluster Registry. Archive logs. You can keep your transportable table spaces related backups, which is transport set data files, and you can keep your ASM SP file. All these can be kept. So categorically some of the things that you cannot keep here is log and trace files. So database log and trace files cannot be kept onto ASM. Now when you keep any of these files onto ASM, there is in a subtle way the contents are allowed to be stored on a disk group. So whatever you store, obviously any one of them, is stored as a set or collection of data extents. So when you store a file on a given disk group, the file is chopped into pieces and each disk will receive certain number of data extents. The file is striped across all the disks in a disk group, and while giving the name of the file we use plus as an identifier that it is going on a certain disk group. So here's a sample query. It's nothing but a union to find out where all my files are. So I said data file from the data dictionary view, temporary files, Redulog file, control file and SP file. I'm running this query against my database instance. You can see it here. It's already there. So all of them are onto disk group. So whether it's my control file, data files, Redulogs, SP file or temporary file, all of these files belonging to your database can be kept on a ASM disk group. The only thing to understand here is how is that whole contents are being striped. So when I store, let's say, a data file, I'm talking, let's say system01.dbf. Don't be worried about the name because Oracle never allows you to select a name of your choice in case of ASM. But I'm assuming hypothetically I'm talking about storing a system01.dbf data file which is of 100 MB onto a disk group, let's say plus data. Number one, you cannot select a file name. Oracle will give the file name of its choice because internally whenever your files are stored on ASM, Oracle uses OMF, Oracle Managed Files feature, where you cannot influence your name onto Oracle's ASM naming convention. And there is a very defined naming structure. Once we take a deep dive into the disk group related discussion, that time I am going to talk about why are certain names being allowed, why it doesn't allows you to give your own name to the files that it keeps onto ASM. The primary reason as of now is OMF. Oracle follows its own convention called as Oracle Managed Files. So when you store a data file, let's say system01.dbf of 100 MB, and I am assuming that my disk group data is with normal redundancy, having two failure groups, where each failure group has, let's say, 4 disks. Then within FG1 I have disk 1, disk 2, disk 3 and disk 4. Within FG2 let's say I have disk 5, disk 6, disk 7 and disk 8, and I am now suggesting Oracle to store my configuration into this particular disk group. Then number 1, the files are stored as a collection of data extents. I am going to elaborate further on to what is a data extent. So each disk will receive one or more than one data extents. A data extent is made up of allocation units. So the smallest size is an AU size. Multiple such AUs will make data extent, and each disk in a striped manner would receive a couple of data extents. So when I store my file of 100 MB, this disk will receive a couple of data extents which is made up of AUs. This disk would receive data extents, this disk would receive data extents, and this disk would also receive data extents. And then the contents are mirrored in another failure group. So the same data would be redundantly written here. One thing very important, nowhere I said there is a disk to disk mirroring. It's a failure group to failure group mirroring. So if I have written my data extents for system01.dbf here, that doesn't mean whatever is written here will be written here. That doesn't mean whatever is written here will be written here. That doesn't mean whatever is written here will be written here. That doesn't mean whatever is written here will be written here. But one thing is for sure, whatever is written in failure group 1, same data is redundantly written in failure group 2, may or may not be on the corresponding disks. So we are looking for redundancy, not a disk to disk mirroring. We are looking at only maintaining the data in a redundant manner. So if one of my disk fails here, then the data can still be retrieved from the other failure group. There is no disk to disk correspondence in this case. It is quite possible, although it seems somewhat unlikely, that why would somebody do it this way, but this is quite possible, that I have 6 disks in my failure group. Each of these disks is of 20 GB. So what is my failure group capacity overall? My failure group capacity is 80 GB. But while creating another failure group, it is quite possible that the corresponding disk sizes may not match, but the corresponding failure group size is still the same. So in this case, when I store stored my file system01.dbf of 100 MB, the entire file was chopped into pieces of 1 MB mostly. Multiple such 1 MB pieces were clubbed together to form a data extent, and each disk would receive a couple of data extents until my entire 100 MB file is equitably distributed amongst all the disks in my primary failure group. I am assuming FG1. Then whatever is written in FG1 would be redundantly written in FG2. Now the problem is I do not have 4 disks. So whatever data extents were received in FG1 by 4 disks, those same number of extents would be received by 2 disks in case of FG2. What we expect is redundancy. So there is no disk to disk correspondence. So mirroring is still possible. This is the advantage in ASM which you don't get to see in RAID 1 mirroring. So there is no extra disk space wastage. So remember a case where in yesterday's session I said you bought two disks, one of 160 GB, another of 100 GB, and you try to club them together in RAID 1. So what is the effective usable size? Only 100 MB. But the investment you made is in 260 GB. Here that's not the case. Disk need not be of same size as long as you ensure that the failure group sizes are same. Mirroring can still be achieved. Next is understanding how the files are distributed. So I am talking about ASM files, extents and the striping method. ASM can use variable size data extents to support larger files. So it's not mandatory that each data extent is exactly equal to any other data extent going in that particular disk group. The data extents themselves might vary. This reduces memory requirements because I don't have to cache the locations of multiple data extents in memory. If I have larger size, few extents compared to smaller size, huge number of extents, memory would be required more in second case, isn't it? Because those many extent maps now needs to be stored in memory of your ASM instance. So to improve performance, Oracle keeps on that data extent size quite flexible. So in some cases, probably 2 AUs might make a data extent. In another case, 20 AUs might make a data extent. Getting my point? This is just for an example. Each data extent resides on an individual disk within a disk group. Data extent consists of one or more AUs, allocation units. A data extent size is equal to AU for first 20,000 extents. So if my file is large, what will be the size of a data extent? Exactly equal to the size of a AU. So if AU is 1 MB, my data extent size is also 1 MB. So first 20,000 pieces are decided during using the AU size. So consider that my file is of 8 GB. So first 20,000 into 1 MB AUs are scattered across all the participating disks. Now my file is even bigger. How much I can address with 20,000? Only 2 GB file. 20,000 MB is nothing but 20 GB. So what if my file is larger than that, 32 GB? Then in that case, Oracle will allocate the next extent, which is multiple of AU, then equal to 8 AUs for next 20,000 extents. So first 20,000 extents will be of 1 MB. Then next couple of extents beyond that will be of 8 MB. So in one data extent there will be 8 AUs of 1 MB each. If the file is even larger than this, then there will be 64 AUs in one data extent. If you see, this is quite similar to segment and extent sizing. So first couple of extents are of 8 blocks. Then next couple of extents are of 128 blocks. Then next couple of extents are of 1024 blocks. So on the similar lines, the data extent sizes are decided. So if a file is small, probably a data extent is of 1 MB. If file is larger than 20 GB, then first 20 GB allocation of data extent is of 1 MB. Later data extents are in multiples of 8 MB. So 8 MB data extent, and these data extents are striped across all the participating disks. So when you store a file, those file pieces in the form of AUs and subsequently in the form of a data extent are scattered across all the participating disks in a disk group if it's an external redundancy, or across all participating disks in a failure group if it is with normal or high redundancy. ASM stripes files using extents, which could either be decided using a coarse method or which could be either decided using fine method. This is called as striping style. So Oracle might adopt coarse striping or Oracle might adopt fine striping. In a coarse striping, AU size is 1 MB. So in a coarse striping, 1 AU is equal to 1 MB by default. So when you don't mention, then 1 AU would be of 1 MB. In case of coarse striping, 1 AU is equal to X MB if while creating a disk group you have mentioned non-default AU size. Understand this. While creating a disk group, you need to mention AU size. If you do not mention, default is 1 MB. So if I am talking about such a disk group where you didn't influence or change the AU size is of 1 MB, which means if I do a coarse striping on such a disk group, the AU size will be 1 MB. But consider another case. I created another disk group. While creating that disk group, I selected AU size as 4 MB. And now I am thinking that Oracle is doing a coarse striping. Then in that case, the AU size will be 4 MB. So whatever is the disk group default is the size of AU. In case of fine striping, the AU size is of 128 KB. Now why Oracle uses these two different styles? That depends on the nature of IO that you do against a given file. Some files you do a bulk IO against. Example, data file, temporary file. But some other files you don't do a bulk IO. Example, control file. Do you do a bulk amount of IO against a control file? No. Tiny bits and pieces of IO against control file. So depending upon the file type, Oracle decides what striping style it should use. For all other files excluding control file, it will adopt coarse striping method. Only for control file, it will use fine striping, which means my file will be chopped into 128 KB pieces, or my file will be striped using chopped into 1 MB pieces, or my file will be chopped into pieces of AU size that I have selected at the time of disk group creation. I am going to ASM command prompt. I said ASMCMD-P, going to disk group data, going to rackdb, going to control file. I said ls-l. What type of a striping style it has used for control file? Fine striping. If I go back to data file and I say ls-l, what type of a striping style it uses? Coarse. If I go to online redulog, what type of a striping style it uses? Coarse. If I go to temp file, what type of a striping it uses? Coarse. If I go to parameter file, what type of a striping it uses? Coarse. So except for control file, all other files are striped using coarse method. Clear? What is the relevance? Because we need to find out what would be the size of AU. Why we need to worry about AU? Because multiple such AUs will be allocated in the form of data extents. Data extent is nothing but the space allocated onto individual disk in a ASM disk group. Clear? So this is how the whole data is stored. So when you store a file, first Oracle decides what would be the striping method. coarse or fine. If it's a control file, it will adopt a fine striping. If it's a any other file other than control file, it will adopt coarse striping. So it has to decide how many AUs, what should be the size of each AU. So assume that I am talking about a disk group with all default parameters. AU size will be 1 MB. So first 20,000 pieces of those files will be of 1 MB each. Each disk will receive those pieces 1, 2, 3, 4, 1, 2, 3, 4 in this order in a round robin manner. So my file is broken into several pieces and those pieces are scattered across all the participating disks in a failure group or in a disk group depending on the redundancy factor. Then next 20,000 pieces will be of 8 MB and next pieces will be of 64 MB. Clear? So in this way the data extents are allocated and this is how the file is striped across all the participating disks in a failure group or in a disk group. Next is understanding about the redundancy. We said for a disk group you can select any of the three redundancy styles: external, normal and high. For external redundancy, the supported mirroring levels, redundancy levels are unprotected because disk group itself is unprotected. So I said create a disk group dgext of the redundancy style external, then no file will be redundantly written. That is the supported mirroring level. Means anything that goes on this disk group is purely on the mercy of the underlying hardware protection, if at all it is there. If it is not there, even a single disk fails, the entire disk group fails. The default mirroring level for this one in that case is unprotected. But if you talk about normal redundancy, then normal redundancy requires minimum 2 failure groups. I said minimum, meaning I can go beyond 2. So I can create 3 as well. In which case you can influence what type of a mirroring is desired. Normal redundancy disk group supports two-way mirroring, three-way mirroring as well as unprotected, no mirroring. Default style however is two-way mirroring. Remember yesterday's question. I said there is a disk group DG normal with 3 failure groups. That doesn't mean by default my file will be 3-way mirrored. My file will anyways by default 2-way mirrored. That's what I said here. Default mirroring level is 2-way. That doesn't mean it will be always 2-way. If you think you need more than 2-way mirroring, then you can create your own template and opt for unprotected or 3-way mirroring. But to do a 3-way mirroring, your disk group DG norm must have minimum 3 failure groups. Now there's a relevance here. I'm jumping out of context. While installing grid infrastructure, OUI asks whether to use ASM or CFS NFS, shared file system. Assuming that you select ASM, next it prompts you to create a disk group. Remember during installation it has shown you a list of all ASM disks, out of which we selected, cherry picked only the first 2, and then we said name of the disk group is data, redundancy is, we said external. But assume that you are trying to create a disk group with normal redundancy. So how many disks were visible? 4. I can consume all 4. But if you create a disk group now with a normal redundancy with 2 failure groups, minimum is 2. So if I on the OUI try to create a disk group with normal redundancy and 2 failure groups, Oracle will reject that disk group. Question is why? So I am writing it just to make a note of it. Assuming that you select ASM, next it prompts you to create a disk group. Understand this. While installing the grid infrastructure, OUI asks you whether to use ASM or cluster file system or a shared file system. Assuming that you selected ASM, next it prompts you to create a disk group. So it takes you on the disk group screen where it prompts you what should be the name of the disk group, what should be the redundancy style, and which of the detected disks you would like to put into that disk group. I am assuming you selected data as the name, redundancy style as normal, but you selected only two disks. One is part of FG1, another part of FG2. And then you click next. Oracle outright rejects that disk group. Question is why? It won't move further until you create a disk group with normal redundancy, but at least with 3 failure groups. This is not mandatory, right? Oracle allows you to create a normal redundancy disk group with 2 minimum failure groups, but during installation it doesn't allows you. It says normal redundancy is okay, but 2 failure groups are not okay. I need 3. Question is why? So the reason why it doesn't allows you to select normal redundancy with 2 failure groups, but more than 2 is okay. So normal redundancy is okay, but 2 failure groups in it is not okay. So that's why if you select a disk group with a normal redundancy, the mandatory criteria is that the disk group must have minimum 3 failure groups. But if it is external, no problem. If it is high, no problem, because high will anyways have 3 failure groups. Next is high redundancy, which maintains 3 copies. So whatever goes on this disk group by default is 3-way protected. If you are not happy, create a template, change the protection style. Next is understanding what all ASM utilities are available. There are multiple ASM utilities for administration purpose or for reporting purpose. However, I am worried about the client part of it, which acts as a ASM client. Oracle Universal Installer acts as a client, because while creating a database, while installing RDBMS, on one screen it says, do you want to create a database? You said yes. It asks you the database. Then it asks you shared file system or ASM. The moment you said ASM, on the next screen it shows you the name of the disk group. So your OUI actually connects to the ASM instance if it is running and displays you the disk group. So OUI acts as a client for ASM. The other ones are quite obvious. Like DBCA, there is an utility called as ASMCA, ASM Configuration Assistant, which again connects to the ASM to fetch information. Oracle Enterprise Manager OEM, SQL Star Plus, ASMCMD command line utility, listener control utility also fetches the ASM instance status. If you see LSNRCTL status, you will find out the listener indeed connects to ASM. The server control utility SRVCTL for starting and stopping of database as well as ASM instance, and XMLDB interface, which allows you FTP and HTTP connections to ASM. So you can connect using FTP protocol to ASM. You can connect using HTTP protocol to ASM to browse the files if you want to take a backup. Now consider a classic case, although nobody is going to do this in real life. I want to copy this SP file. How would I copy? There are multiple ways of copying. ASMCMD command line provides you a CP command, but this CP command is only for them, those who have a physical access to the server. What if my account is not there on the server? What if I'm not authorized to log in to the machine where my ASM instance run? Then in that case I cannot obviously connect. Use RMAN, because RMAN can do a remote backup. So connect to ASM, take a copy of this file. What if I'm an RMAN, I'm scared of RMAN? Now I'm talking about a hypothetical case. I'm not describing your attitude of looking at RMAN. Most of them are scared of RMAN. They said no RMAN. So everything related to that is okay, but R-Man is not okay. So He-Man, Superman is okay, but not R-Man. So what are the other methods of copying the file? So you can still get connected using FTP and HTTP method to the ASM and can download a file which is like a child's play. It's not very realistic in the world, but assume that somebody wants to get connected remotely, who is not technically inclined on using an RMAN utility, who does not have an access to the ASM environment, the server, then how do you download files from ASM disk group? In which case you can start an FTP and HTTP interface for your database and can still download it. That more than that I will show at a later stage how to copy files. Anyways, we still have time. Let's do it. There are multiple interfaces. As I said, I am going to show one at a time. Currently my database is in no archive log mode. To be able to simulate it in a true manner, otherwise people would say, why are you trying to copy a file which is in use? To avoid this, I will translate my database to archive log mode first and will try to simulate a typical hot backup, manual hot backup, where you put the database in begin backup, then start copying the files to a safer backup destination, and once that is done you do an end backup. So I am trying to replicate the same thing. To do this, first I need to stop my database. So I am stopping my database, after which I will only start my current instance, convert the database to archive log mode, and then bring up all the instances. So one way to copy file is use ASMCMD CP command. Another way could be DBMS file transfer PL/SQL package. Another way could be FTP, HTTP, XML/DB interface. Another could be RMAN. The only method that is widely used is RMAN. So there could be multiple ways of dumping a file from an ASM disk group to a file system for whatever reasons. I am starting my current instance now. After which I am saying alter database archive log. I changed my archive log destination to the the, the disk group itself. I am shutting down. Now I can bring up both the instances. I wanted to use srvctl instead of logging in. No, not required. So now I am saying srvctl start database hyphen d rackdb, both the instances would be started. After which I am going to query again uh, the archive log status, and that's the system ready for our simulation. So these are just the cosmetic things that I am taking care of, has nothing to do with the demo that I wanted to show. So once my database is up and running, I will show you different methods of copying file from a ASM disk group to the file system. Clear? So it's now in archive log mode and my archive destination is data. Assuming that I want to copy file belonging to the user's table space. Which is this. I select this file just because of the size. This is the tiniest file on the entire ASM. So I said alter table space users begin backup. Once done, I am here on ASM. I said where is that file? So this is the file. Now I can say cp this file to tmp directory. Remember, this cp is not an operating system command. The cp is a ASM implementation of the OS like cp command. So the file is copied. I am coming out of this one. I am going to tmp. Here's my file. So this is like an manual hot backup. After which I must come back to the database and say alter table space end backup. Anyways, the file copy is done. I am going to remove it. So ASMCMD copy command. Next is dbms file transfer. So I am on my database instance. I am describing the package dbms file transfer. There is a procedure called as copy file. So see what this procedure takes: an argument, source directory, source file, destination directory, destination file. So I must know where my file is. This is my file. So I am saying create directory srcdir as whatever. Create directory target dir as /tmp. So now I have source and target directories. Now I am saying execute dbms file transfer dot copy file. What argument it expects? Source directory object name, which in my case is src dir. Source file name, which in my case is the target destination name is tgtdir in my case. What should be the name of the file that you would like to copy? user01.dbf. Clear? The file is copied. How do I know? I go to tmp here. See, there's a file now with the name user01.dbf. So using dbms file transfer, I am removing it. Not required. Third one is to take an rman image copy. That is anyways possible, but you can always do. I said rman target equal to slash backup as copy data file backup as copy data file 5 not 5, 4. So it will do a copy. Where is the output file copied? If you are not mentioned a format, the file will be copied elsewhere. You can always override by giving your own custom format. Here is my file. So you can always take a backup like a image copy. I am removing this. Last, you can use FTP HTTP XMLDB interface. Prior to that, I am showing you listener CTL status listener. Understand this. Which Oracle home I am into? The listener anyways runs from grid home, but status can be checked from anywhere. You can see it that the listener is running from grid home. So I am checking the listener status. I wanted to make a note of this. So here I am on to grid home. Clear? I said listener status. Make a note. That's it. I am logging into my database instance. Once I am logged in, I run a script. Name of the script is cat xdbdbca, which is to enable XDB support, XMLDB support in my database. I am running it. It will prompt me for two values, FTP port number and HTTP port number. I am saying. So it says enter FTP port number. I said 7070. It says now enter HTTP port. I said 80 or 7171. That's it. Wait. So it registers raw presentation layer with the listener using FTP and HTTP protocol. So wait. So in our case, FTP is 7070, HTTP is 7171. Done. Once done, come back and check the listener status. See the listener's endpoint listening location before and after, especially these two lines. So it says now there is a 7070 listener listening on the endpoint with the presentation layer as FTP and 7171 with the presentation type as HTTP. Now I am launching a browser, a local browser from my machine. And then I am going to the website, whatever is the IP address of alpha. So it is listening on where? IP address of alpha, which in my case is this, on 7171, which is my HTTP port. It says give the username and password. Type the database system user and password. It takes you to the website. I go to sys. I go to ASM. See, you see the disk group now data. Now you see group 0 and RACDB. Go to RACDB. I wanted to copy a file, data file. Right click on it, say save link as. I am saving this file with whatsoever name, users01.dbf. See here, the file is copied using an HTTP interface. I am removing this. I am logging on to some machine because I don't know Windows FTP commands. Windows FTP is somewhat weird. I am logging into some other machine whatsoever. Let's say DNS server. Now I connect to my FTP website. I said FTP 172.168.200.2, which is actually the IP address of Alpha, port number 7070. It says what's the username. I said system, password. Then I said dir. The same whatever I saw in web browser is also, you can see it here. I said sys ASM data ragdb data file dir. See, all those files are visible using FTP. I enable a binary transfer mode. I said bin. I want a hash progress bar. I said hash. I then said FTP command get. File is transferred. Bye. Bye is to quit from FTP. See, the file is here. Clear? Interesting. So there are multiple different ways using which you can copy a file from an ASM disk group to file system. On the local server, use cp command. On the local server, use rman backup. If you want to do it remotely, use dbms file transfer. If you want to do remotely, use FTP HTTP interface. The only problem with FTP HTTP interface is if you bounce the database, the listener will stop listening on 70707171. If you want to re-listen, again run cat xdb dbc. You can always rerun cat xdb dbca to get those listener ports re-enabled again. So as of now, in this session, we talked about the part 2 discussion, understanding ASM, understanding disk group, a further discussion on how the space on a disk group is allocated. So this is actually the second part, video number 3.